Hi everyone, we are Group 22 from Section 10. My name is Yo Ziqi and my group member is Lim Jin Sing and Derek Hauser. Today we are going to discuss about a experiment report which topic is calibration and sensitivity measurement of light-dependent resistance. So before we start the experiment, we already know that the objective of this experiment is to calibrate a light-dependent resistor by establishing a relationship between its resistance and the intensity of incident light. And we also want to measure the sensitivity of the LDR by determining the change in resistance for a given change in light intensity. So the apparatus that we have using is light-dependent resistor, Arduino board, breadboard and jumper wire, bulb with dimmer, lux meter, and 10 kilo ohm resistor for pull-up. So we already follow the procedure to set up all the apparatus in this experiment. And for the data analysis, we already get the result of this experiment, and this is the proven of our result, which is the 2374129 like this. So for the LDR resistor, we use this formula, which is R pull out divided by V reference minus with V out times with V out. So we get this value, and after we getting all the result of this, we have a graph plotting, and we just put in the result and plot it, and we connect it. And for the sensitivity calculation, we use the highest value of the resistance and the last and the lowest value to get the change of it. So we get the result is negative 11.3284.
So now we want to connect the circuit with the LED series communications. After following this step, we will get the connections like this. And after we get this, we can start to simulations. So this is the simulation wave of the resistance per times of the LED bills apps. When we eliminate the LDR sensor, the amplitude will be dropped like this. Next is the discussion part. From the graph we drew above, we can know that when light intensity increases, the resistance of the LDR sensor decreases. Because photon exits the electron in the semiconductor, this electron moves more freely, decreasing the resistance. However, error also exists in this experiment. The light surrounding will make the light intensity measure different with the light captured by the LDR sensor. Then, the angle at the light strike the phone's ambient light sensor and LDR sensor also be changed in this process, since the naturally tight met the error. Lastly, the negative sensitivity proved the inversely relationship, which is negative 11.3284 ohm per lux.
In conclusion, the experiment successfully calibrated the light-dependent resistor LDR and established the relationship between light intensity and resistance. The result showed that the LDR resistance decreased as the light intensity increased, confirming their inverse relationship. We also integrate LabVIEW with Arduino to acquire and visualize sensor data in real time. The waveform graph displayed in LabVIEW made it easier to monitor and analyze the sensor response. Overall, the objective of calibrate the LDR, measuring its sensitivity and demonstrating real-time data execution, will successfully achieve. And this is our reference. We use the Wikipedia contributor and the electronic for you LDR light dependent resistor. That's all. Thank you.